before we get started. And just double check that I can see myself here. Yeah, there we go. All right. Well, welcome everybody to Microsoft Developer. This is the first time I'm streaming on this channel. So I am Aaron. I work for Microsoft as a cloud developer advocate. And I focus on Go, the Go programming language, and containers and Kubernetes and cloud native software. So Go and Kubernetes and containers and all of the things that I talked about kind of fit really well together. So if you haven't heard of Kubernetes, Kubernetes is a portable cloud. It's sort of like a portable cloud, if that makes sense. And the point of it is to package up these things called containers. And containers are sort of like very stripped down, limited amount of features, virtual machines. There are many technical differences between virtual machines and containers, many. And so they are definitely not equivalent. There are many features that virtual machines have that containers do not have. But the general overarching idea, and the reason that I say VMs are similar to containers, is that you can package up your entire app in a container and you can deploy it and you can run it locally as well. So I'm going to be showing how to write Go code, and Go is used actually to implement containers and Kubernetes. So I'm going to show how to write Go code, how to package it up in a container, and then how to deploy it to Azure as a container. So the first thing is Go. So Go is a relatively new programming language, and it provides a really easy way. Hey, Captain Badrook, nice to see you. Hello. So Go provides a nice way to write what we call systems level programming. So generally speaking, it's really optimized for systems level programming. And what I mean by systems level programming is we're talking about things like building databases or building web servers, which is what we're going to see today, or building other types of lower level systems. So Go is very different from Ruby or Python in that kind of sense. It would not be the best choice for something higher level. So we're gonna, Andrini, how can I compare it to Python and C#, at least on the high level? So Python is an interpreted language, and that is one of the main differences from Go. So Go is compiled, and it compiles down to a single binary. It doesn't have outside dependencies like an interpreter, like Python would have. And it also doesn't have what's called a runtime. And the runtime would be something like the CLR for C#, or generally the .NET platform. So Python is code that's interpreted by the Python interpreter, and C# is code, it's bytecode specifically, that gets run by a runtime, and that would be the CLR. And from a language sort of user programmer level, Python does not have what we call types. So types in Go specifically are when you declare a variable, the variable then has a specific type, like a string or an integer, or a custom type that you define. And then in the compiler, in Go's case, it won't let you reassign that variable to a different type. So if I say the variable is an integer, I can't set it to a string later on. The code will literally not compile. So Python's different. So Python A doesn't have a compiler to enforce any of this for you. But by default, Python does not have types. So you can set a variable to a string and then reset it over to an integer and then reset it later to a custom class that you built. Now, Python does have static analysis software that does give you types. And that's a relatively new development, and it's very powerful, and I highly recommend you check that out. But at the base level, that's the difference between compiled and interpreted and typed but non-typed. Now, C# has types, and it's very powerful. It has a very powerful type system. It does have a compiler as well that will enforce those types. So in that sense, it's similar. But the difference there, the major difference there, from the technical level. And that's not at the use case level, but more of the technical level is C# is not a self-contained compiled binary. It requires that runtime. So Vijay, so Go is the next way to go for service-based development, can we say? Well, I can't say it is the only way to go. So it's a very good choice for services. However, I never want to say it's the best choice. That is certainly up to you. It's up to your preferences, and it's up to your very specific use case. So I can't say it's the next way to go because nothing is going to be 100% the best thing. But it is a very good choice, and I highly recommend you check Go out. In fact, if you go to golang.org, you can actually try Go right here in this window. T. Shorsh, I think that might be how you pronounce that. How does it compare to Rust for system development? So Go and Rust are the same in some ways, and they are different in other ways. So they are both compiled, they both are typed, they both have very strong concurrency primitives, or that is to say concurrency support. But Rust is slightly different, sort of niche. So at the technical level, they're fairly similar, but Rust is a slightly different niche in that it is highly optimized, among many things, it's highly optimized to be memory safe. So in Rust, it's very, 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 very difficult to have a null pointer exception, or if you're doing concurrency, to have race conditions between your variables. And that's built into the compiler. So you literally, in almost all cases, you literally cannot compile Rust code that has a memory problem like a null pointer or a race condition in concurrent code. Whereas Go, it's more lenient on that side. It's very possible to have race conditions and null pointer exceptions in Go. And that's just because there's a slightly different use case there. So VJ would love a discussion on Go and Rust as systems programming languages, maybe in one of the subsequent episodes. Sure, yeah, I think we may be able to do that. And then the last one I'll take for now before we get started, BP Dynamite, how does Go compare to a language like VBA? So I haven't used VBA in, I believe, 15 years or something like that. So I can't speak very well to this. The only thing I remember is that VBA is most definitely not compiled, whereas Go is. And that would be probably one of the major differences, or some of at least the bigger differences, is that Go compiles down again to that single binary, and the binary has everything you need all inside of it, and you can ship it off to anywhere else. So you can build a binary on a Mac or Windows, and you can compile it with the target of Linux. And once you build that binary on your Windows machine, you can ship it off to a Linux machine and just run it directly on Linux. All right, so let's get started. So first of all, I mentioned golang.org. Highly recommend you just check this out. Downloading Go, if you click on this link, it's as easy as on Windows or Mac running an installer, or you also have the option on all platforms, including Linux and BSD, to download a binary and the standard library files and move it to the right place and just get started. So fairly easy to install. You just go and you click on this link. It takes you to golang.org/DL. Click on your platform of choice and you can get started. So I have Go installed already. And the way that you start up a Go program is fairly straightforward. You can, in fact, do it all from the command line. So I'm going to just create a new directory. I'm going to call it MSDev, or Microsoft Developer. And once you're in your directory of choice, you simply run the Go tool. So the Go tool is simply called Go on the command line. You call go mod init, and then you specify the name of your application. Now, in Go, it's a standard practice, and in my opinion, it's the best practice, to name your program after the place that you're going to be putting it online, on GitHub or GitLab or wherever else. So I prefer GitHub for all of my code, public, at least all of my public code. And I like to put everything onto GitHub, as many things onto GitHub as I can, just because then I can have it in a central location. And then I can bring it down onto my laptop later when I'm on the run, or anywhere else that I need to. So I am going to be pushing this code up to GitHub later on. So I'm going to name it after where I'm going to push it onto GitHub. So that's github.com/ar/msdevdemo. Let's call it that. All right. So, Andrini will go work in Visual Studio Code Bases. Code Spaces. Yes, indeed it will. So Visual Studio Code Spaces supports any container. And so what that means is you can pre-install pretty much anything you want, including Go. So it's actually very easy to get Go working on Visual Studio Code Spaces. And there is, let's see if I remember, somewhere on GitHub. I can't remember off the top of my head in the moment. Maybe someone in the chat has seen it. But there is a pre-built code spaces environment for you just for Go. So if I have time later on, I'll go search for that during the stream. If not, I'll get it on the chat afterwards, after I can find it. So we've got our Go app set up. So if we look in here, Go mod init has created a go.mod file. So I'm going to open up VS Code. I'm going to use the code CLI tool, the code command line tool, and I'm going to type code space dot. So what this is going to do is open up Visual Studio Code, and it's going to open it up into the current directory, which is what I want. So it'll take just a moment, and we are in. So here is that file that was created. Okay, so there's two code lines. One is the module name. So the module is approximately equivalent to the application name in Go. Module is a little bit more generic than that. It has an additional meaning on top of the application name. But for our purposes today, this is going to be the application name. So we also have the minimum version of Go that my application will require to run. All right, so as Go progresses, it aims to be very, very backward compatible. Almost everything in Go is backward compatible as you move forward in the Go versioning. And there's in fact what's called the Go promise, the Go compatibility promise. So that means that anything V1, if you're in Go V1. Let's say 1.13, if you write code and you download Go version 1.14, the Go command line for Go 1.14, your code that you wrote for Go 1.13 should still compile. So we have the minimum Go version so that I know that if I write my code that uses all the features from Go 1.14, I should be able to compile it even after Go 1.15 distribution comes out. So now let's go create our first Go file. We sort of have a standard in the Go community. This is a sort of a best practice, let's put it that way, to call the first file in our Go app and the entry point to our Go app, meaning the place that you write the code that should be executed first before anything else. The standard is to call that main.go. So Praneeth, what are the other technologists going to learn? What do they learn along with Go? So that's a very good question. That's an important question. So thank you very much for asking that. I think it's a hard question for me to answer because it really depends on what you're aiming to do. So if you're aiming to write some low-level database, you'll probably have to learn things like file formats and database layouts and things like B-trees. And if you're writing a distributed database, meaning a database that has to run across multiple machines, you'll probably need to learn a lot of sort of distributed systems things. But on the other hand, if you're using Go like I'm going to use it today to write a web API, you'll probably need to learn things like HTTP and things like JSON, both of which we'll cover today. And you may need to learn things like GraphQL, which is another technology built on top of HTTP, and possibly some authentication technologies like OAuth, and it goes on and on from there. So I'm sorry that I can't answer that completely because it depends on what you're going to do, but I hope that's sort of a little bit of a taste depending on what you're going to do. So T-Shorsh is Go always backward compatible. So the Go language is backward compatible as long as you're in version 1. So Go, the latest version of Go is version 1.14. So there is no later version of Go. So all the official Go 1.0 releases are backward compatible. So if I wrote Go for Go 1.10, my current Go compiler, which is, if we go check it out, I am at 1.14.1. If I wrote code for 1.10, and at the time Go 1.10, that compiler was the latest one. If I compile that code with Go 1.14.1, it should still compile and work the same. So Rockerboo, hello, good to see you. Thanks for coming out. And let's start our program. So all Go programs, if you are writing an application, so not a library, not something that someone else is going to consume, but this is an executable application that I'll be able to run, you have to have 2 features on your first file. And by the standard, the first file is main.go. You have to have something called package main. And a package is sort of a logical grouping of functionality. So package main is the entry point to my app. And you also have to have a function called main. So func is how you declare a function. Func is short for function. So in Python, you would do something like def main. And in C or C++, you would do something like void main. In Java, you would write a big class with a static final void main, and so on. But in Go, you just do func main. So Brave Cobra 2, what languages go most similar with? I know a couple of others, but I found the syntax very funky. The syntax in Go is fairly, I would say that it's fairly familiar to C, but it has many differences that are borrowed from other slightly lesser known languages. Especially if you go and check out the concurrency in Go, it's borrowed from a lot of other languages. So Go has one of the fewest numbers of keywords in the language. So that keyword would be something like func and package and so on. So it's a lot simpler than many of the other languages that are sort of in the same class or the same use cases. It's hard to say what it's the most similar with, but if I had to say one, I would say C. But that's not completely like an objective analysis. It's sort of also the feel that I get from writing Go as well. So I hope that makes some sense. So Captain Badrick, thank you for the correction there. It's not just int main. It's got arguments and it's got count of arguments and the arguments itself. And Brave Cobra 2, you're mainly a C# and TypeScript developer. You'll find Go very different from C# and TypeScript. One of the major differences is that it does not have classes. And it also has, like I mentioned before, far fewer keywords. So there's less to remember when you're writing Go. So func main, and now we're going to start writing our web application. So first things first is what packages, what libraries are we going to bring in to write our app? So if we go to golang.org, actually, let me go to a different Go site. If we go to a site called go.dev, this is where you can find documentation for all of the public Go libraries in the ecosystem. So go.dev will have a tab called Discover Packages, and it takes you to pkg.go.dev. And this has all the documentation. This is auto-generated documentation for not only the standard library of Go, so that's the libraries that ship with Go, but it also has documentation for every public repository on GitHub. And I mean everything. So if there is a public one out there that is not in here, this will either crawl and go find it based on other libraries that import it, or you'll be able to submit it, and from that point on, the pkg.go.dev tool will remember it and will continue to crawl it. So if we search for a library called net/http, we'll see that this is the standard library's built-in support for HTTP servers. And we're going to use this to write our REST API. Okay. So I'm going to scroll down. You can see there's a lot of examples here. These are all examples on how to do HTTP clients. So that would be having your code make requests out to other HTTP servers. But we also have how to do HTTP servers. So this is the simplest code, and it's very powerful and effective and performant code, actually. So it's the simplest way to take advantage of the performance of Go's HTTP server. So I'm going to copy this into my code. And you can see there's a lot of red squigglies here saying undeclared name, HTTP. And we see more over here. And we see here. We see logging is undeclared. And we see HTTP again is undeclared. Now, I haven't pressed save yet. So when I press save, the squigglies should go away. I think I've configured everything correctly. So let's see. Yes, the squigglies have gone away except for foo handler. Now you can see what was added here. All these imports. So this is me, my code, importing all the libraries that are needed in order to compile this code. We'll get to this squiggly in a second. But I just want to point out that this was enabled by the Go VS Code extension. So you can go in and just search for Go in the extensions marketplace, and you'll find the Go extension developed by the Go team at Google. And if you download this, it will set up everything you need, including this automatic import thing that I just showed. It'll set all of that up for you, and you'll be ready to go. There's the pun. You'll be ready to go. And in fact, after you set it up, it'll even show a little a little notice in the output console that says you're ready to go. Brave Cobra, is there a package manager like NPM or NuGet? Oh yeah, and Anand, thank you for answering that. GoGet indeed does fetch packages. By default, it will fetch packages from a proxy server that is hosted next to this pkg.go.dev site. The proxy server is called proxy.golang.org, and that'll happen transparently for you. But it is not exactly similar, as Anand, thank you for saying that. It's not exactly similar to NPM or NuGet. So you can indeed use GoGet, and you'll find that GoGet tracks your dependencies in this go.mod file. And it also has something similar to the package.lock that NPM has, and that'll be called the go.sum file. So the minute you start using dependencies in Go, I won't be doing that today, but the minute you do, you'll start seeing that go.sum file pop up. So yeah, Brave Cobra, it does handle versioning in that way. Oh yeah, Ananth, you're all over it. Thank you. Thank you for that. So Praneeth, what kind of job market of Go versus .NET, Python, Node, Java? And is it a good time to invest in Go 1 now, where Go 2 is releasing shortly? So I'll try to do a quick answer because I could talk about that for a very, very long time. So for the job market, Go is a much more specific market, and it's mostly around doing backend systems. So you won't find a lot of Go jobs for writing mobile apps or anything like that. But there are Go jobs out there for writing web apps and REST APIs, and even backend systems that don't get called by HTTP and aren't front-facing out to the internet. That could be things like databases or internal services that handle handle databases or glue together lots of different cloud services. So that's where it sits. Is it a good time to invest in Go 1 now, where Go 2 is releasing shortly? Yes. Yes. So Go 2 is not going to be like the Python 3 and Python 2 split. Go 2 will build on Go 1, and it will most likely be backward compatible to Go 1. So investing in Go 1, understanding Go, is going to be very, very important for understanding the new features that are added to what we are calling Go 2. So, yep, Brave Cobra, check out the Go extension. It will happen in your VS Code if you get that extension. So, yeah, DOM effects, glad that it's interesting. We're going to actually continue. All right, so we've got this http.handle, and we've got a foo handler. So let's stick with the foo path. So this is going to be the HTTP path that is going to be handled by foo handlers. So that is when the Go server is running, and this is a built-in HTTP server. The HTTP server gets started right here. When the server is running, if you make a curl call or you point your browser to the server/foo, the foo request will be handled by this foo handler. Similarly, the bar request will be handled by this function right here. So handlers in Go look like this. Let's actually do this. And lots of code here, but I will explain this in just a moment. Okay. So one more parentheses there, and we have two different ways to create a HTTP handler. One is http.handle, the other is .handlefunc. So handle requires that you pass in a thing called a handler. Now, there is a way to write a handler that's much more complicated than this, but I've taken a shortcut. There's something called a handler func. So a handler func is a way to take in a function itself. Now, this is called an anonymous function. So this is a function that does not have a name and is only going to be used inside of this http.handle call. So this is an anonymous function, and it looks exactly like this function down here on line 15. All right. So essentially, unless I have more complicated logic, it's much better to use this http.handlefunc. Okay. So I'm actually going to delete the http.handle, and we're going to stick with http.handlefunc. Okay. So this is the function handler. This will get executed. This will get executed. The executed is the wrong way to say that. This will get executed every time a request comes into /bar. Okay. And if multiple requests come into /bar at the same time, this will get executed concurrently. So there may be multiple instances of this function running at the same time. Okay. Now the function will be passed an http.response-writer and a pointer to a request. Now I'm going to gloss over pointers for now because it's not super important. So all we need to know here is that we get the request that came in and a way to write out back to the client. All right. Now, let me grab a drink of water. And after that, inside of this function, we're simply writing out hello back to the client. So fumped, our format. So this is the package that does string formatting and printing out. And in Go, it's sort of hilariously to me called fumped. So fumped.fprintf is going to write this string out to W, which in other words is writing the string out back to the client. So that would be your browser, or curl, or another client, another HTTP client out there that is deciding to make a request to our server. So before we move on, let's see this thing in action. So when you want to run it, there is a way to run it in VS Code, but I prefer the command line. Sometimes I like VS Code, but right now I prefer the command line. So we're going to go and do go run. All right, so this is the way that you run your code. So you execute go run, and after that, you can just do go run. I'm sorry, you cannot just do go run. You have to specify the files that you want to run. So the files that I want to run are in the current directory. So I'm just going to say dot. And at this point, it's going to compile. It shouldn't be taking that long. Let's see if we can build it. There we go. Ah, it didn't take that long, in fact. So what happened when I did go run, and this always gets me, what happened when I did go run was it compiled all this code, and then it started running the server. But it didn't print anything out. So it looks like it's just hanging, but it's not. It's already running. So that, after writing Go for a long time, maybe 6 or 7 years, I can never remember. This always still gets me. So I'll put a log line in there before the server runs in a second. But for now, let's test our server out. So we're going to want to do a curl command to port 8080, and we're going to want to curl to /bar. So I'm going to head over to my other terminal tab, localhost port 8080 /bar. All right. So we have printed out hello and then the path that was requested. Oh, VJ, the yellow background is awesome. How do you set that? You get a theme. And this, I believe, yeah, this is the Gruvbox Lite theme. So head over to the VS Code Extensions tab. Just search for Gruvbox. And once you're there, download it and then set the theme to Gruvbox Lite medium, parentheses medium. And you'll get this. You get the yellow background, you'll get this font, and so on. Captain Badrock, yes, I did indeed install the Go extension for VS Code. It was a one-click install. It gave me everything I needed, all of the other tools. It gave me the autocomplete and the IntelliSense like this. It also gives you autocomplete and built-in documentation and more. And Anath, oh, what is that's for Brave Cobra, the missing imports, yes. All right, so we have a question. Ananth, you are asking, what is an easy way to cache dependencies globally and not per project? So they are by default cached globally on your machine. They're also cached globally in the cloud at that proxy.golang.org server, but they will be cached on your machine as well in a globally available locations. Usually it's under a thing called the Go path, which I won't get into now, but it's stored in a globally available location to all your projects. Yes, Ananth. Yeah. I'm sorry, that's what you're asking. There is no node modules directory taking up several gigs per project. Well, there can be. There is a specific way to vendor. It's called vendoring in Go. There's a specific way to vendor your dependencies in Go. And before the most modern dependency management system came about in Go, the sort of node modules directory way of doing it was the default way. But these days, there's a new strategy for doing dependencies. It's called Go modules. And that allows us to sidestep the node modules issue with Go. But it is still supported, so kind of depends what you're trying to do. DOM-FX, can you debug by running from the command line? You can. It's also available inside of VS Code if you want the IDE way to do it. Yeah, Ananth, you're all over it. Thank you. You can use delve. Delve is what's used inside of the VS Code IDE debugging experience. You can also use GDB. It's a lot harder to use than delve. GDB is better to use for C and C++, of course, but it does work with the debug symbols on Go. Oh, the Stone Cold Man, I didn't know it was called Groovebox. not sure. Maybe I'll start calling it that from now on. All right, so let's put a log line before our server starts up, and that way we'll know. We'll know that it started. Port 8080. So we actually don't need this F. I'll explain what printf means later on if we can get to that. So we're going to go back, run this thing again, and now we have a notice that the server is starting up. All right. So before we get any fancier with our server, I am going to write something called a Docker file. Anand, thank you. Thank you for answering the question. Sorry I double answered it. I appreciate your reply. So we're going to create something called a Docker file. So now we're moving into the realm of creating a container. All right, so this is going to be the way that we package up all of our Go code. We build it into a binary. So that would be the executable binary. And then we build that into a Docker image. So Docker is a technology that can build these containers that I was talking about before. Once we build the Docker image, we'll then be able to run it locally, and we'll also be able to run it on Azure. So I am going to be a good developer, or at least do what all developers do. And I'm going to go and copy someone else's Docker file that does Go builds. So this is from a project, an open source project that I work on, and it has a lot more than needed inside of its Docker file, a lot more than needed for our experience, but I am going to copy and paste it in. I'm going to delete everything that we don't need, and then I'm going to explain what's going on. So we're going to set a workdir. And msdev is the name of our project. And we're going to delete a few of these things. Go build. Here's where we do our go build. Now go build is like go run, except we're only building the binary. We're not going to run it. We're just going to build it, and later on there will be an executable there for us to run. All right. Don't need that. Let me go back to check out what the Alpine version was. All right. So let's do a checkpoint here. All right. So we've got this code all the way through line 7. So we have a from, and the from is saying from Golang 1.14-Alpine, Golang : 1.14-Alpine as builder. All right, so this is saying this is going to be our base image. So this would, in other words, this would be the Docker image, the package with all the utilities that we need to build Go. We're going to base our Docker file on that. So this is kind of a jumping off point. It's going to have everything we need to build our Go code and everything we need, in fact, to run it as well. Although we're not going to run it, we're not going to take advantage of that functionality to run it in this case, up to line 7. We're going to be putting ourselves into a default working directory. We're going to be copying all the code in. So that's basically just the main.go. And then we're going to be building our code. So we've got our go build -o. So this is going to be building the code. We're going to output the the resulting finished product binary into /bin/msdev. And then again, we're going to be putting a dot here. And the dot is going to indicate that we want to build the code from the current directory. Then we on line 9, are specifying a new base image. All right, so we're wiping the slate clean of the old base image, and we're specifying a new one. So there's a lot here that we don't need. I'm going to delete a few things. And the one that we do is copy. So we're going to be copying from that previous image, the builder image. This is what we named it, builder, here on line 1. We want to copy /bin/msdev into the local /bin/msdev on the current base image. So what's going on here is we are creating one image here. So we're jumping off from this base image, Golang 1.14. And now we're specifying a new image that we're going to jump off from Alpine. So this is Alpine Linux. If you haven't heard of Alpine Linux, definitely Google it. It's really cool. It's a very small Linux distribution that turns out to be very good for building Docker containers. All right, so we're going to be copying our resulting binary from the last image that we are building. We're going to copy that before we throw it away, before we throw the previous image away. We're going to be copying it from /bin on the previous image into /bin on this image. So we don't need this or this. We need to expose port 8080. And we're going to get rid of that. And we're going to have a command. This is the default command that we're going to be running when we start up the container. And we want to run at bin/msdev by default. Okay. So, Brave Cobra, yes. I'm going to let Ananth take that question. Ananth, you are my hero for answering all these questions, so thank you. And the other mods too. Bit and Bang and Eric.dev, both of you, thank you as well for being here and answering questions. All right, so let's take this file. Let's build our app into a Docker image. Okay, so again, Docker is a tool that we're going to use to take our Docker file and our code and build it all into an image, a container image that we're going to be able to run locally and on Azure. And we're getting, we've got about, 17 minutes left. So let's see if we can get through this, the Docker part, and get it running on Azure. So just like with Go, you saw me do a Go build inside the Docker file. We're going to be doing the Docker build now on the command line. So again, you can do all of this from VS Code if you want. But I love the command line. I'm a Linux person, so I'm huge on the command line. And in fact, I can't go too deep into this because of time. But this terminal right here and the code that I'm developing, the code and the terminal are all Linux. So this is Windows Subsystem for Linux 2. Definitely recommend checking that out. But the bottom line for now is I'm running a full Debian build. So this is Debian that you're looking at, even though I'm running Windows. So we're going to do Docker build -t, and the -t is going to be the name of my image. So I'm going to call it ar//msdev, and this is going to be the name of my image, whether it's local or up in the cloud. And just like with Go Build, I'm going to specify the files that I want to use to build my image. So I'm going to do a dot again. You could do // or you could do the full path to the directory. But if you're in the directory that you want to build the Docker image from, dot is certainly the best way to do that. And I have been having a few troubles with my Docker install, so bear with me. I got this working about 20 minutes ago and it stopped. So this is because I'm running Windows Insider's dev ring, the fast ring. So things break from time to time, and this should fix it. It has a workaround. msdev. Let's try that again. /msdev. There we go. So a few things we're seeing here. First of all, and there's a lot of moving things here too, so that means something's working. So first of all, we've got steps. Step 1 of 8, step 2 of 8, step 3 of 8. So each step is a line on my Docker file. So step 1 of 8 is that familiar from Golang Alpine as builder. It has to pull down that base image from the public Docker repository. So that's here. And then we're setting our current working directory. Not much work needed there. We're copying the code in. We're building the code. And then we're done with that first image. And then the second image, we start here. I already have that image cached locally, so I didn't need to do that. And then we've got copying the binary from the previous image. Not a lot of work there. The Go binaries are relatively small, depending on the Go version and amount of stuff you have in them. Generally speaking, the amount of code and other assets that you have in them. But generally speaking, they can hover around 10 megabytes or so, which is fairly good because they have the entire runtime, garbage collector and concurrency and lots of other things. It's all built into that binary. So we copied that binary from the previous image to the current image. Very cheap operation. We're exposing the port, another very cheap operation. Specifying the default command to run, also very cheap. And we're done. All right, so whirlwind tour through how a Docker file gets built. Let's run it though. So Docker run, we want to do /p, and this is going to expose ports. So I want to expose port 8080 inside the container, and I want to map that to outside of the container. All right, now the image name, and we should be good to go. All right, so there's our log line. Let's see again if we can curl that from another tab. And what was it? /bar, I think. /bar. All right, so it worked. So now we've proven we can run it directly on our machine. Now we can package it up into a Docker image and run it on our machine. And then it works in both of those cases. Now let's use the last 13 minutes to try to get this thing running on Azure. All right. So we are going to run the container on Azure, and there are a few different ways that you can do this. The one way that I'm going to do it is using Azure Container Instances. So let's put that in the chat. And Azure Container Instances is one of the easier ways to take a container and run it on Azure. In fact, run containers without managing servers is why it's one of my favorite ways to do it as well. It's completely serverless. You literally just say, I want this container to run in the cloud, and the container is running. It'll get restarted if it crashes, and you can even get a public IP address exposed to the internet. It'll even give you a domain name. It's not a custom domain name. It's one of the Azure domain names. But you get publicly exposed containers exposed to the internet. Now, it's not the most secure thing. By default, it doesn't come with an HTTPS certificate or anything like that. But for a quick spike or a prototype like this, it's a very effective way to get code up into the cloud. So I am going to use the AZ command line. If you don't have that installed, go check out, just go Google, install the Azure CLI. The install instructions for this are fairly simple. They obviously differ from platform to platform, but in any case, fairly simple to install. At that point, you'll have to do an AZ login. And after you do the AZ login, that'll require your Azure cloud credentials. And then at that point, you'll be ready to go. So the command that I'm going to be using is AZ container create. Let's see the help text for AZ container create. And scrolling back up to the top of the help text, you can see we're doing something called creating a container group. All right, so we've got two things. We got one thing required, the resource group. The other thing that I'm going to use is going to be the -- image. That's going to be the image that I just created. So that's ar//msdev. And I am going to specify a DNS name label. All right, so this is going to give me that public IP, and it's also going to give me a DNS subdomain under the Microsoft ACI subdomain. All right. I'm also, for good measure, I'm going to specify --IP address. I'm going to set it to public as well. So let's open this in a new tab. AZ container create. Resource group is Twitch. I had already set up a Twitch resource group. I'm going to specify the --image. MSDev. I'll do IP address as public. And let's do a DNS name label of MSDev Twitch. Try that. And might take just a second. I forgot the name. Let's do a -n MSDev Twitch. So this is going to be the name of the Azure container running on, or the name of the ACI container running on Azure. Different from the name of the image. So what this means is I have this MSDev Twitch. I could change the image that it's running and still be called MSDev Twitch no matter what image it's running. And might take just a second. And let's go. Oh, the image is not accessible. And the reason for that is something I forgot. I forgot to push the MSDev image up to a Docker repository. All right, so the MSDev image lives on my local machine, but it does not live in anywhere that Azure can access. Forgot that part. So it's really important that we do this. Now, by default, the Docker command line tool, there are many different command line tools to deal with containers, but the Docker one that I'm using by default will push to Docker Hub. All right, so that's hub.docker.com. However, you can push up to Azure as well. So there's an Azure container registry that you can push up to as well. And there's a little bit more configuration to do to get that working. But either will work. And I'm going to use the default for now. And it will take just a second to finish the push. It looked like that part of the image was 7 megs. So yeah, it's about 7 megs. So lots of... it's a lot smaller actually than I said. I said around 10 megabytes for just the Go binary. This was a little bit smaller than that. So we've got an AR//MSDev now on the public internet. So anyone can Docker pull it. But ACI is going to Docker pull it. So while that happens, Praneeth, where was that? What are some project ideas to build and learn Go as self-taught and useful for profile building? I would say the best place to start is to build a web server like this. Think of something that's interesting to you. I love building weather APIs just randomly. So I like building weather APIs to learn like a new language. I learned Python that way back a while ago. I actually tried to learn F# that way. So that would be one thing to try. And another thing to try, this is actually sort of related to Go, it's in the same sort of realm, is to try to deploy that API to the web. You can do it for free. So this ACI deploy is actually under the free tier. I believe, yeah, this is under the free tier, so you can do it for free. And it's good sort of for your own confidence, for your own skill, and also can be used for profile building if you push the code up to GitHub, which is also free. All right, so we have something running now. 5 minutes to go as well, so that's pretty good. Let's check out this domain name.
Ladies and gentlemen, and welcome to the greatest show on earth.
And let's curl it, since we've got, this is an API, not really a website. And /bar, and this should not work. and it's hanging. So why? Why did this not work? The reason is the ports. We did not specify that we wanted port 8080 to be exposed. So you can see -- ports default is 80. So this gets me every time. This time I did it on purpose, but every other time this gets me. So you have to remember to specify -- ports 8080. All right, and so you can do an AZ container update, and that does, in this case, effectively the same thing as AZ container create. So I'm going to be overriding the settings of the MSDev Twitch ACI instance. And the override is essentially going to be changing port 80 to port 8080. So that is running. Oh yeah, and Eric.dev, that's a good point. A small API server or a command line tool. Command line tool is a great option too. And Praneeth, if you are interested in a command line tool, there is a great framework called Cobra. So just search for Cobra, COBRA, Cobra Golang I'll just put it. I'll put it in here. Cobra Golang, and we'll see here. This is a great framework to check out if you're going to build a command line tool. All right, so let's see if this will work. We're going to curl that domain name, port 8080, and then I keep forgetting. I think, yep, it was /bar, and it works. So this is available to everyone. It didn't render completely. The port 8080 didn't quite get there. But anyone should be able to curl that. And that is powered by Azure Container Instances. So just to recap what we've done here. First things first, we did a go mod init that created this file. This file is generally auto-generated. You most likely will not have to go in and edit this file manually. All right, so you can, but it's most likely going to be the case that you don't need to. And that means that when you do a go get to pull down a third-party dependency, the go get will automatically fill this out. Next, we created a main.go. And we had the two major features of any Go executable program. So not a library, something that actually runs. Package main and func main. And then inside the func main, we put all the code that we want to run when the Go program or the server starts up. So we've got our HTTP handler that's going to handle the /bar path. We wrote our function that's going to handle it. Just as a reminder, the function may be running concurrently, so don't have the function access global state or global variables, for example, because that might be a race condition. Inside the function, we are writing hello back to the client. That's what the W is here. And we're printing out before we start the server, and then we're starting the server. Then we created a Docker file. So this is doing two things. First, all the way up to line 7, we're building our Go binary. That's the go build -o. And then we are taking the binary and packaging it up into the final Docker image. And that Docker image is going to have port 8080 exposed. And by default, when you start it up, it's going to run our Go program. And then finally, we ran AZ container create in order to push our... Well, actually, we did one more thing in the meantime. We did our Docker build, and then we did a Docker push to access, to allow ACI to access our Docker image from the public internet. So then the final thing we did was AZ container create. And what that did was we told Azure to pull down that Docker image that we just pushed, that we just did that Docker push. It pulled it down, and then it ran it in Azure Container Instances. And at that point, we had our Docker image running on the public internet at this domain name, msdevtwitch.westus.azurecontainer.io, on port 8080 with this public IP. And if my container ever crashed, ACI would automatically restart it. So I also get things like I can see logs from the Azure portal. I can see logs from the command line as well. There's other things. You can set up monitoring and log aggregation and so on. It's connected in with all the other features in Azure that you would expect. All right. So 2 more questions. I'm going to take 2 more questions. So AbuMask11, how does Go compare to other language for image processing and recognition? It works. I lost it. Oh, yeah. So it works, but it's not commonly used. So Go is used for some AI and ML tasks. You can also get Go bindings to things like OpenCV, which would do image processing for you. And I actually do know someone who uses OpenCV to apply it to some robotics applications with Go. But I don't know of a lot. I don't know of a massive ecosystem in Go that does image processing and recognition. Now that could change because Go is still expanding in use cases and there are still new use cases being discovered, but that's just at the moment. And why do people want generics in Go? Is it for generic containers like trees and stuff? Well, generics is, it's gone through a few iterations. So there have been, I think, 3 like non-trivial proposals that have gone in for generics. The latest one is, I think, the most widely accepted one. And it's also, of course, had the most work and consideration put into it. But it's still early enough to have many different use cases. So many different folks have submitted use cases that they want to use generics for. For me, my two biggest things that I'm excited about, at least for generics in Go, are being able to do functional programming and being able to do, like you said, generic containers like a queue or a tree or what have you. So that's for me. I wouldn't say that's for everyone. I'm certainly not going to speak for everyone in the Go community. But those are my top 2. Those were not in any particular order, but those are my top 2. And the final thing I'll say is I suspect that the majority of people who want generics, one of their use cases is going to be for something like generic containers. Excuse me. All right. So that is all the time I have for today. I wish I could stay longer. I wish I could compare. Compare, contrast Go with other languages and explain more of the Docker stuff and get more into containers and what have you. But I only have an hour and I am 3 minutes over. So I want to say thank you so much to everyone coming out, asking questions. Do tune in again to Microsoft Developer. Do make sure to subscribe if you haven't. And I should be back doing more Go stuff. I'll be doing it on my channel, AR Schles, same thing as the GitHub name. And I should also be back on Microsoft Developer as well, doing more Go stuff, doing more container stuff, and cloud stuff, of course, too. I work for Azure. All right, everybody. Take care. Have a great rest of your week, and hope to see you soon.